So in this video we're going to talk about the concept of the function. What is a function? What is the domain of a function, and what is the range of a function? Well, a function is, if you like, a mathematical rule that for each x value gives exactly one y value. And it's important that the rule only gives one y value, otherwise it's not a function. And some other important concepts to do with functions is the domain of a function. What is the domain of a function? Well, it's the allowed x values of a function. And another important concept is the range. And the range is the allowed y values. Carrying on talking about functions. So one example of a function is the stopping distance for a car, which can be modelled by a function. So what happens? Well, we can think of the function like a rule which maps. Here we have the speed, which we are going to define as x, which will be mapped onto the stopping distances, which we'll call y. And the rule that's going to convert speed to stopping distance is what we call the function f of x. F of x. Now the values that we put into the function is called the variable is called the independent variable. And the values we get out of the function is called the dependent variable. So my independent variable is x, and my dependent variable here is y. In this instance, f of x is equal to 0.03 times x squared. That's the formula, the mathematical formula. The domain is going to be the allowed speeds that my car has. For example, I cannot have a negative speed, so my lowest value of the domain is going to be 0, and typically cars can only travel about 120 kilometers per hour. So the allowed values of x, the domain, is going to be within this range, or within this domain. So x is greater than or equal to 0, but less than or equal to 120. In this instance, the units of our speed is kilometers per hour. And the range is going to be the values of y that come from the domain. So for example, the lowest stopping distance I can have is going to be 0, because 0.3 times 0 squared is 0. And if I was to put in 120 instead of x and calculate that, I would get the largest value of the range, the largest y that is allowed. Now, there are different ways to describe a function. One is by using words. Another is by using the formula. Another is by drawing up a table of values. And finally, we can also represent the function by its graph. So if we looked at our example with the stopping distances, in this case we could say that the stopping distance is proportional to the square of a car's speed. And the formula I showed on the previous page could be y equals 0.03 multiplied by x squared. The table of values is a table of x in the left-hand column and y is in the right-hand column. And here I would just put in some typical values for x and y. In this case, I know my x's can't be negative, so I put in 0, 10, 20, 30, for example, and I have to calculate the y's. So if x is 0, y would be equal to 0.03 times 0 squared, which is 0. When x is 10, y would be 0.03 times by 10 squared, which is 100. So 0.03 times 100 is 3 meters, and so on. And then, for the graph of the function, I have to put my function in a coordinate system. In this case, x on the horizontal axis and y on the vertical axis. And if I use a graphical calculator, or if I plot my table of values as coordinates and join them up, then I would get, in this case, a curve. And I could find off the values of y by going from, if I wanted to say, for example, to find the stopping distance at 40 kilometers per hour, I would go up from my x-axis to the graph and then read off on the y-axis. Now I'm going to go through a number of examples. Let's have a look at this graph here. This is the graph of the function y equals 20 multiplied by 1.25 to the power x. And we are asked to use the graph to read off when read off the value of f of 0 and b, f of 10. So this is pronounced f of 0 and f of 10. So what we have to do is, remember the number in the brackets is the x value. So when x is 0, we're actually here on the y-axis. So I start from here and I go up to the graph and then read off. So f of 0 is actually where the graph intersects the y-axis, if at all. So f of 0 equals, in this case, I can read off that it's equal to 20. This is the y-intercept. How about b then? When I'm looking to find the value of f of 10. So I go to 10 on the x-axis, go up to the graph, and then read off. Now I can't read off an exact value, but it's somewhere between 180 and 200. F of 10 is roughly equal to 190. Let's look at example number 2. I'm asked to work out, I've got the following. I've been told, let f of x equals 2x minus x squared. That's my function. I've then got to calculate f of 5, f of minus 5, and f of 3a. So if I want to work out f of something, the value of the function for a certain x, all I do is I replace x in the formula with the value of x in the brackets. So let's go and do a. F of 5 is therefore 2 times 5, replace the x with 5, minus 5 squared. 2 times 5 is 10, minus 25 is equal to minus 15. How about f of minus 5? F of minus 5, same thing. 2 times minus 5 instead of x. Then minus, now I have to keep brackets here because I've got a negative number, minus 5 all squared. 2 lots of minus 5 is minus 10, minus 5 times minus 5, which is plus 25. But since I have a negative number in front of it, then it becomes negative. So this number becomes f of minus 5 is equal to minus 35, minus 10, minus 25. Now what happens when we don't have a number but an algebraic expression here? I've got 3a. Well, it's the same thing, I just have to replace x with 3a. So f of 3a is 2 lots of 3a minus 3a all squared. And we just have to then simplify. 2 lots of 3a is 6a, minus, the square here applies both to 3 and to a, so we have 3 squared lots of a squared. So this becomes 6a minus 9a squared. In our third and final example, we have two functions. Let f of x equal 3x minus 4 and g of x equals 5x minus 3. Notice here that here the function is called f, and here another function, which is a different function, is called g. So the choice of the letter f is actually arbitrary. We can choose any letter we like. We have to then solve this problem. Find x such that f of x equals x, and in b, f of g of x equals x. In the b part of the question, this here is called a function of a function. Sometimes you might hear that being called. So what are we actually asked to do here? Well, here we're not given a value of the function to work out. We have to find x. We have to solve an equation. So we do that by just replacing f of x with the formula for the function given here. So 3x minus 4 equals x. And now we have to solve for x. So the way we can do that, there are a number of ways of doing it, is first subtracting x from both sides. I get 3x minus 4 equals x minus x, and x minus x is 0, and on the left hand side I have 2x minus 4. Then I have to then add 4 to both sides, and I get 2x equals 4, and finally dividing both sides by 2 I get x equals 2. Part B is a bit trickier. What do we do then if instead of f of x we have f of g of x? Well, I start with this function, f of x, but wherever I see an x, I replace that with the function g of x. In this case, 5x minus 1. So f of g of x is 3 lots of, because the 3 is in here in f of x, lots of, but instead of x, I take 5x minus 1, which is, this is then g of x, the whole of g of x. Then minus 4 from f of x, and all of that has to be equal to x according to this equation I'm trying to solve. So first we have to do a multiplication. 3 times 5x is 15x. 3 times minus 1 is minus 3, and then minus 4 equals x. So I have to solve this. First I will subtract x from both sides to give me 14x, and I then have to add 7 to both sides to get rid of this minus 7 on the left hand side, so I get 14x equals 7, which leads to x equals a half.